All right. So thank you so much for inviting me. It's the first time I have the pleasure to talk to you guys. So thanks to the organizers and thanks to Jan for also having me here in his own in his garden. So I'm Julian. I'm an evangelist based in France. So you got Italian English and now you have French English, but hopefully we have AI services that can help you understand us. Okay. So tonight I'm going to talk about a new service that was launched at re:Invent called Amazon Athena, which is yet another data service. And so we're going to look at it, and then we're going to have like a death match, between Athena and Redshift, and we'll see what we can learn from that. And so obviously it's a brand new service, and I was looking for a nice logo to put, in the right-hand corner like I do all the time. And guess what you find when you Google Amazon Athena? You can try it. That's what you find. And that lovely lady is a professional wrestler, right? So not quite what I expected, but on second thought, I think that's quite interesting. Because Athena, our own Athena, right? It is a data wrestler. So what is this service? It was just announced, re:Invent, a few days ago. It was great. We're still very jet-lagged, at least I am. And in a nutshell, this service allows you to run queries, interactive SQL queries, directly on files stored in S3, right? So just dump your files in S3, they're probably already there, and just run SQL directly from there. And the cool stuff about Athena is there's no loading, there's no pre-processing of data. You just create a table, I'll show you how, map that data to your files, map that table to your data files, and off you go. The best thing about Athena is that there is absolutely no infrastructure, right? Zero, none. You don't see it, you don't create it, you don't manage it, you don't see it, right? So our website calls it serverless. I'm not super comfortable with that because I think it's gonna create a lot of confusion with Lambda. But it is serverless in the sense that, yes, there are no servers at all, and you just fire away. As often, for now, it's only available in the US, so I'm going to show you how to use it in the US East. But I'm quite confident you guys will all be yelling, and most of Europe will be yelling at AWS to bring this to the European regions. How much does it cost? Well, as always, it's pay per use, and in this case, you pay per data scanned. Right? So it's $5 per terabyte that you scan, which means that the less you scan, the less you pay, and we'll see how to do that with a couple of techniques. Okay, so it's based on Presto. Anybody using Presto already? Nobody? Well, I know it's Facebook, but come on. All right, no one using Presto. Okay, so it's a cool service. It's a cool service, and actually you could already use it on an EMR cluster. But you had to go through the process of creating an EMR cluster and messing with that nice Hadoop ecosystem. So today it's much simpler. How do you run queries? When anything that deals with table creation is not going to be standard SQL, it's going to be Apache Hive DDL, right? Which is close enough to SQL, but slightly different. Anything else, the actual querying, the DML, so the selects and so on, they are NC SQL, so totally standard. All the operators, all the functions that you would expect to see, I'm going to use some of them, they're there, right? So literally the doc says, if you want to find out what Athena supports, go to the Presto doc, and that's what we support, right? We have a number of restrictions. We don't support user-defined functions. We don't support any kind of transactions, and we don't support stored procedures, right? But, I mean, standard SQL that you would expect to find, all the operators, they're here. How about data? So that's the interesting part, because your data lives in S3, and it has probably many different forms, and such as unstructured, right? Log files, Apache log files in particular, which you can load in Athena using regular expressions, custom mobile expressions. You can have semi-structured data, CSV, TSV, etc. And yes, I believe JSON is semi-structured, right? So let's not get there. And finally, oh yeah, maybe after the presentation. And a couple of more interesting formats like Parquet, which is actually a French word, and Orc, which are columnar formats, which I'm sure you know if you've worked with Hadoop and Hive and so on. And being columnar formats, they're extremely efficient, and we'll look at that. Compression is important too, and we support a number of algos. Unfortunately, we don't have LZO, sorry. And why is that important to have compression? Because just like in Redshift, if data is compressed, you just have less I/O, and you scan less data, and so you have better performance, and you pay less, right? So using compression, being able to read compressed files in S3 is actually gets you that double benefit. Partitioning, again, partitioning is a technique that has been around forever in databases, and it's there in Athena as well. You can either have pre-partitioned data in S3 that you're going to load in Athena, or you can partition your data at creation time. And again, partitioning will allow you to reduce the number of IOs that you do, and that gives you, again, better performance and savings. So if you combine compression and partitioning and columnar formats, you probably will get extremely good performance at a very good price. So how do you actually run queries on Athena? So you can do that in the AWS console. And before you guys start throwing stuff at me, it's actually a quite cool console for once. I know we're not experts at delivering consoles that people love using, but this one I'll show you is actually pretty cool. There's a very nice wizard to import your data. There's a nice SQL editor with auto-completion. You can save queries. You can see query history. You can run multiple queries in parallel, etc. So, kudos to the Athena team for actually taking care of people who want to do interactive stuff. Still, I suspect most of the time, you won't be using the console. You'll be using the JDBC driver with, for example, Workbench or directly from your own code. Okay, and we provide, just like Redshift, there's a specific JDBC driver that you can install to connect to Athena. Okay, so very quickly, how do you set that up? Because I'm showing you this because it took me a while, so I'm figuring, I might not be alone there. Just install the driver. Those are all the correct names. And there's probably only one catch, is that you need to add a property in Workbench with an S3 bucket to output the data, to output the results from your statements. And silly me, but the bucket needs to be in the same region as Athena. So if you're using US East 1 for Athena, your bucket needs to be in US East 1. Okay? The data that you load apparently can come from other regions. I tried using it from EU West 1, from Ireland to the US, and it worked really well. A little slower, but it worked. So this is just for this output bucket, all right? Saving you 10 minutes of frustration, probably. Okay, and you're all set. So, okay, I think you get the idea. Maybe I can show you the console in 5 seconds, and then we can talk about how this compares to Redshift. So that's the console here. Okay, so can you read okay in the back? Yeah? Just yell if that's too small, okay? So the query editor, saved queries, history, etc., etc. And here I created a table, and I can, I can select some lines. Oh, session expired. That's lovely. It's going to make me sign in again. Oh, come on. Okay, sorry. The joys of multi-factor.
Make a note of that number really quickly.
Yeah, well, that's going to be good for like 30 seconds, huh? All right. Okay, so you can just you can browse your table and you can run some queries. That's my data set. We'll talk about that. Okay, you can see all the queries here with the execution times and how much data you scanned. And remember, that's important because that's the pricing that applies, basically, the cost. Okay. So here's the console, and again, I could connect through Workbench and do exactly the same thing with the benefits of the nice data explorer, etc. Okay, so it looks like a database, right? Nothing complicated here, no nightmare to expect on setup. Okay. So how can we compare these to Redshift? So, well, I don't know, to be honest. So what I did is I created some clusters. So actually, I created a small Redshift cluster, an expensive one. I created a larger one, more expensive. And I created a table for my data set. I loaded all that data in both clusters, and I ran some queries. Okay? And I'm going to do the same thing I've done the same thing for Athena. I created that table. I'm running the same queries, looking at the numbers and trying to figure out what is what, right? So Athena, creating a table in Athena is literally pointing to an S3 bucket, listing the columns in your files, giving them a name and a type, and that's it. And for my data set, it took less than 5 seconds, maybe less than 2. Okay, so it's really just click, and that's it. My data set is, as you will see, is 12 gigabytes compressed. Okay, so every time I do a full scan on my data set, that's what it costs. Okay, fractions of a dollar. Okay, really cheap. And of course, I've got unlimited storage in S3. Okay, I did the same thing on my small Redshift cluster. Okay, 4 nodes, DC1 large. Okay, which is pretty much as small as you can get with Redshift. Took me 6 minutes to create the cluster and a whole whooping 38 minutes to load the data. Okay, yeah, that should be glowing red. That's way too long. But again, DC1 large has very low I/O. That cluster costs me $1 an hour, about a third of that if I'm doing reserved instances. Okay, and the bigger one was way faster, but much more expensive. Okay. So yeah, you see what my conclusion is going to be already, right? There's a big difference here. So the data set, it's one table, it's 1 billion lines of fake e-commerce transactions. So no, I didn't I didn't steal some logs from Amazon.com or something. They look like that: last name, first name, gender, state, blah 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 blah. It's a CSV format, 10 columns, and this is actually 1,000 compressed files in S3. Okay, this is what I'm running queries on, and this is what I'm loading in Redshift. Okay, so it's not tiny, it's not huge either. It doesn't have any joins, but it's large enough to give me an impression of what's going on, and small enough that I can demo it. Okay, make sense? So table creation, just to show you what it will look like based on that data set. On the left, you have the Athena command with the Hive DDL. Okay, and don't worry, the wizard will generate that for you. And on the right, that's the Redshift creation. And the only slightly interesting thing here is that I'm using the state as the distribution key, and I have a sort key as well. Okay, and this is the actual heavy command, the one that takes 38 minutes on the small cluster. Okay, so pretty familiar. Okay, so here are my queries. The first one, we'll try just a couple of those, and of course you get the slides and everything, so you can replay it if you want. Counting how many cells I've got, so just fully scanning the table. Looking at what the average basket is for men and women, and we know the answer to that one already. Finding out when women spend most, right? Guess what? It's Christmas time because they're buying us gifts, that's why. The top 10 states where they spend most, and the top 10,000 women who spend most in those 10 states, right? So this makes no sense at all. This is just to create, some slightly elaborate statements queries that I can run, okay? And doing some full scans on the systems, okay? So you want to try maybe, yeah, let's try one of those, okay? On all three, see what happens. Okay, so let's start with the Redshift first. So that's the small Redshift cluster here. So let's do the bigger one. Come on. All right, okay. So let's run that. Let's run it on the powerful Redshift cluster too. And let's do it on Athena, okay? Interestingly, this is the exact same SQL code, okay? This is actually a Redshift demo I've been doing for a while, and I literally took the exact SQL code I was running on Redshift for a while, copy-pasted it, and with one very small exception, and I don't have to explain it, it ran out of the box on Athena. So that's good news if you have all those SQL statements ready somewhere. Yeah, run, that's the one here. Okay, off it goes. So the larger cluster is done in 5.7 seconds, right? And I've got those 10,000 customers here. While the small Redshift cluster is still going, that's scary. And Athena is still going. You can see the time flowing here. Ooh. So, this is scary. Oh yeah, it's loading the rows. Okay, so yeah, so that doesn't really count because then it's no. Now look, I'm counting the answer to first row. It's like time to first byte, right? It's okay, so that took about 40 seconds, okay? And that one is probably stuck because that should never be that slow. Okay, so I'm going to cancel it, and something went wrong here. Maybe that's just my SQL tool that timed out. I don't know. Okay, so what do we see here? We see a large Redshift cluster is quite fast, and I didn't go through the crazy optimization that you can do on Redshift, you know, literally. Yeah, this one is just probably dead. Okay, that's all right, die. Let's try that again. And we see Athena doing it in, you know, about, let's say, 40 seconds, okay? So let's do that again. Show favorites, yeah. Connect. Or maybe that cluster is just, you know, dead. But it was working okay on the train, obviously. All right, we'll keep that running, see how it does. Okay, so I don't want to spend too much time doing this. I run this a number of times in the last few days. And this is what you get, okay? So, and remember, keep in mind, all 4 first queries do 1 full scan on 12 gigs, and the last one does 2 full scans, okay? So it's interesting to see that Athena performance is really tied to how much data it scans, okay? When it scans twice the data in Q5, it takes twice the time, right? You know, makes sense, I guess, but, you know, interesting to see that in real life. And it's pretty consistent, right? Every time I have to scan my 12 gigs, it takes about 20 seconds, something like that, okay? My small Redshift cluster, the one that I call Redshift here, is for some operations, I mean, for most operations, it's the same ballpark, right? Look at Q2, Q3, Q5. It's about the same performance as Athena, which is totally by accident, right? It looks like I designed my demo that way. It's pure luck. And of course, the 8XL cluster is much, much faster, right? But remember, the one on the left, Athena, each of these queries cost $0.0025, right? For Redshift, in the middle, it's $1 per hour. And if I run one query and then shut down the cluster, I paid for 1 hour. Remember? It's like EC2. And Redshift 8XL is about $19, $20 per hour. So you do get performance, but hey, much more expensive. Okay. So what could you learn from a brain-dead, silly demo like that, right? Well, my take on this is that obviously for this data set, I see no reason why I would use Redshift with a small configuration, because Athena is just as good, right? So I don't know if you could extend that judgment to other data set, remains to be seen, and if you guys do some testing, I'd be happy to know. But it looks like Athena is about equivalent to 4 GCU1 large nodes, right? But remember, when I use Athena, I'm up and running in seconds. When I want my Redshift cluster, I have to go through 6 minutes of cluster creation and 38 minutes of loading time, which drives me nuts, especially if I just have a few queries to run. And of course, I believe you're going to save a lot of money by using Athena, okay? And the serverless comparison starts to make sense, because if you compare Athena to Redshift, I believe you get the same order of magnitudes on savings as in Lambda versus EC2, right? So now the serverless thing starts clicking in my head. So I'm an evangelist, so you should never listen to me and trust me blindly, but I think it looks great, right? Because it's simple, and believe it or not, I hate data, right? I have to use data to get some answers, but what I really want is answers. I don't want to play with clusters. I don't want to do complicated things. I want to ask questions and get answers. So I think people are going to use much more than actually ad hoc queries. I think people are going to do production stuff with it because it's fast enough and it's extremely cheap, right? If you want the ultimate performance, then Redshift still rules. You can optimize the hell out of it. It's slightly more complex, but you can get to sub-second performance on huge data sets. So if that's what you're looking for, Redshift rules. So in the end, would you go for EMR, Redshift, or Athena? Well, EMR is just, I call it the bulldozer, right? You have the mountain of data, you need to move it from one place to another, and you need to use brute force to do that. And EMR is pretty brute force, if you ask me. It's custom everything, it's complicated, but it gets the job done if you have huge data set of unstructured data. Redshift, it scales very high. It can do a lot of very complex processing, ETL, huge joins, etc. It's a Formula One. I love Redshift. You can get to insane performance. And Athena, well, it's just about, like I said, answering questions in minutes. No fuss, no plumbing, no drama. Create your table, ask your questions, get your answers, right? Simple, but still pretty fast. And so, yeah, here she is again. I believe that's going to be my unofficial logo for Athena from now on. Marketing is not going to like that. No? Are they here tonight? Huh? Yay! That's okay. So Athena, in one slide, ad hoc queries, ad hoc SQL queries in standard SQL on your data file stored in S3 in multiple formats. You don't need to create, manage, worry, scale any infrastructure. Performance is better than what I thought, to be honest. It's equivalent to a small Redshift cluster, right? Without the fuss and without the price. And so from now on, if you're looking for a simple, cost-efficient alternative to the existing data services, if you need to run your queries in minutes or seconds and get some answers fast, I believe you should use Athena. And before I go, I don't believe anybody mentioned it, but I missed most of the presentations. So Danilo's book is out, so come on. So yeah, congratulations, right? And please buy it on Amazon.com. Do you have any discount coupons? No, not today. All right, everybody, thank you so much. I'm so happy I could make it to London in time to talk to you. It's a huge group. I'm very impressed. And I hope you like Athena, and I hope to be back to talk about more stuff in the future. Thanks for having me.
Thank you so much, Julian. It was a trip it was well worth making the trip. Thank you so much. I was just thinking about Polly, Athena, Lex. I mean, is this a language we talk at an AWS user group? I don't know where the world is going. Any questions for Julian at all? Yes, we have one over there at the back.
Oh, yeah, sure.
Athena looks very good. One of the things Presto's good at is pulling data from heterogeneous data sources.
Right.
And I can kind of see that being a need where you're like, I've got a ton of data in S3, but I also want to pull in some extra data from MySQL. Any plans for that?
So let me get back up here. So as you know, it's always a risky proposition to make bets about the AWS roadmap, because it changes a lot, and anything I could know and tell you would be, would have a 90% probability of never making it to the actual, production. So I can't comment on the future. I see what you mean, pulling data from everywhere. So what I would do today, or you could have, let's say, you could export, you could want to use stuff that's stored in Hive, for example, right? You have your huge Hadoop stuff running, your bulldozer running all the time, storing data in Hive, and you want to, run some data, some queries on that one. So today, the only way you could do that is export it back to S3, possibly keeping the, let's say Parquet or Orc as a format, because you can do that. If you have MySQL or if you have RDS in general, you could export. I know it's not perfect, but you could export to CSV. You could export to JSON if you're so inclined. But we tend to see S3 as the central repository for all the data in the AWS universe, and probably that's going to be the case for a while. Okay, probably that's going to be the case for a while. It could be that Athena connects to other sources, but I think it would introduce some complexity, because we would need to take into account the peculiarities of MySQL schemas and Postgres schemas, etc., etc. So I think actually exporting all your data back to S3 if needed, but keeping the native format if you can, makes sense, right? But we'll see. Again, if you guys yell loud enough to get an Athena connector for RDS, you might get it. Who knows?
Thank you very much. Round of applause for Julian.
Thank you.